The idea, as requested, was to share a personal example or specific example. I'm sorry I won't be able to do that, as well as my co-panelists. And so I'll just skip to what I'm sure is of interest of just what is the CHIPS program and what are the opportunities, especially for this community, of which there are quite a lot, I would say. Okay. So for those of you who are paying attention, the CHIPS for America vision is a major enterprise passing by Congress in the late summer. And the overall purpose of the CHIPS for America programs are these three things. The first is economic security, resilient supply chains, especially for critical technology like semiconductors, national security, to ensure that these critical components can be produced and manufactured in the United States. And the third part is the future of innovation. And so semiconductor chips and technologies are used in nearly every sector of the economy and will be needed into the future with a lot of the tools and the approaches, especially developed by this community, such as AI, et cetera. And so the US has a very intense interest in maintaining our edge in innovation. The program itself is pretty incredible, something you couldn't imagine even just 6 months ago. It is $50 billion in the Department of Commerce. It's in two pieces. The first one is $39 billion for manufacturing to incentivize expansion of fabs in the United States. So this is a subsidy and grants program. And then there's $11 billion for R&D, but these programs I'll say a little bit more about. And that's the part I'll be focusing on here. So the R&D part is really focused on not just economic and national security, but also the innovation space. So the primary objective of the R&D program is to strengthen and advance US leadership in research and development. And what that means is that even though the semiconductor industry was invented here in the United States, the current state of play is that the most advanced chips are not made in the United States. More than 90% are made in Taiwan, actually. But the innovations that enabled all that manufacturing progress in chip performance has been developed largely in the United States. And so the goal of this program is to create an engine that ensures that the US is still developing, inventing, and producing the foundational technologies for semiconductor manufacturing in the future. So what that means is that we need to make sure that the most important technologies are developed here, not so much on just the volume of innovations, for example, as a counterexample. Now, the way we'll need to do it, it'll be very familiar to the theme of this enterprise, of this meeting, of course, is that there are many pieces within the ecosystem that need to be integrated to enable this innovation. And we're very intentional in using the word integrated rather than coordinated or informed, in that there has to be an intention and a design element for how different pieces are actually connected together, not just able to be adjacent to each other. And from the theme of this meeting and the earlier panels, I'm sure you're investigating these types of approaches and materials data in great detail. For the programs here, of course, we'll be working closely with industry, academia, government, allied nations, and partners. And we're really paying attention to the value proposition for participants from industry, academia, and government to participate in this ecosystem we're building, and also on which technology areas would be the most worthwhile ones to pursue. All of these programs are informed by an Industrial Advisory Committee, 24 individuals that represent the broad range of the semiconductor ecosystem. And they've been providing incredible recommendations and spending a lot of time helping us to formulate what we're planning to do. You can learn more about this group as well as these programs at www.chips.gov. You can sign up for updates that can be sent out through an email mechanism. I'll just say here that the next big stage for the R&D program will be a white paper that's covering this top line program, the National Semiconductor Technology Center, expected by the end of March. And the rest of these programs will certainly be standing up in the near future, in the next few months. So if you have questions about those, I'll just highlight, I can answer them, but I'll just highlight here about the metrology program that is housed at NIST. It's building upon our current and existing activity. and really amplifying it in ways that can show the importance of these foundational measurement science issues for the overall ecosystem. Okay, I'll just wrap up here with just some starting points, and I'm confident that my co-panelists will be providing specific examples in some of these topics. The first part is that what we're anticipating here, been asked to do in the R&D program, is to develop this innovation ecosystem, and we're centering shared data, modeling tools and design, and shared resources, because a lot of the barriers facing the development of new technology in semiconductors comes from the cost of licensing IP or gaps in having enough data to be able to anticipate where the best impacts of a particular technological idea can be realized. So doing this in a very IP heavy and complex technology stack like semiconductors is extremely challenging. To do it at a national and international scale is also challenging. Echoing many of the challenges that we've discussed here in MARTA as well, but also the benefits for doing so. And so we are hoping to utilize the resources we have available and the energy around this as a national priority to make this happen. Now, some of the clear areas are certainly around semiconductor devices and themselves. These are complex systems of materials, many different kinds of materials in close proximity that have to work together to provide the functions of these incredibly complicated devices. Not only the devices like in memory or in logic, but also the packaging components is becoming increasingly complex. And that goes all the way from the computational logic itself, all the way to the packages for thermal properties and thermal management using photons as opposed to electrons. All of these involve a complex system of materials. So some obvious places already that many of you are working in is certainly in the design of devices and systems with improved performance, alternative materials to reduce cost or address other needs like availability and supply chain or sustainability. And I'll just add that it's very important to be able to provide value in the way that the CHIPS R&D programs is designed, is that it's really driving to the performance metrics of the entire enterprise and not just component by component. And the more that if you are participating in a semiconductor related area, that is understood and the context is understood, the greater the likelihood for a large impact. As we say in material science, processing is just as important. And so the manufacturing and processing of semiconductor devices is incredibly complicated with many complex systems like deposition, etch, and lithography. There's a growing trend in the processing space of really moving into digital twins, which is a validation of all the settings that govern your manufacturing process. Now, these models are largely empirical at the moment, but there's certainly a drive to trying to tie them to physical principles, materials, fundamentals, so that you don't have to do trial and error to validate a digital twin of the modeling your entire process, but to be able to do it a priori and to get to new processes quicker. So instead of a 5 to 10 year development cycle, anything that could shrink that would, in this case, provide the United States an edge. Okay, and the challenge here, of course, is there's so many things to look at, is to identify the highest value problems to solve. Now, as a starting point, the metrology program at NIST held some workshops where we worked with the industry to identify grand challenges in measurement standardization, modeling, and simulation. You can read and get this report here at this URL. You can also go to chips.gov to find it. And within each of the sections, it goes into more detail, but I'll just highlight a few areas here where the types of skills that are here in MARTA are really present, and there are plenty of problems where a large impact could be had.